Hi there, guys. So you guys probably already noticed on Thursdays I review the week. What we learned in the week is now that we're ready for either the quiz or test, which is on Friday, right? So this week it's a quiz, but on every Thursday I will review for that purpose. So looking at the first 4 questions, I just gave you guys a picture with mark. So what's the most specific name for that figure? Well, part of it is a trapezoid, yes, because 2 sides are parallel, the other 2 are not. Isosceles trapezoid, nice. So isosceles trapezoid, right? And it's isosceles, right? It's trapezoid because 2 sides are parallel, the other one are not. But this one's isosceles because the 2 sides, the 2 legs, are equal. Right? If they're not equal, it's just trapezoid. If they're equal, then isosceles trapezoid. All right. Any questions on those first 4? No? All right. Moving along. Let's take a look at question number 5. 5 through 8, I use numbers instead of markings. What type of picture is that? It's a what? One thing, if I notice, if I was to rotate it, right, that one is actually spun a little. If I was to rotate it, those 2 numbers add up to 180. These 2 numbers also add up to 180. So that makes it a trapezoid. Right? If I was to spin it around, that would make it a trapezoid. But then I take a look at the legs. The measurements are 10.4. So this is also isosceles trapezoid. Okay. Right. Any questions on the front? Yes. The numbers? Well, let me explain what trapezoids example. Let me explain trapezoids. If I was to extend trapezoids up, one interesting thing that they do is that these 2 numbers will add up to 180. Numbers that I can use will be like 105 and 75. They have to add up to 180. Here, it will also have to add up to 180. And I could use any number. I could use 180. And that will make it a trapezoid. Right? As long as those 2 add up to 180, it will make it a trapezoid. And as long as my numbers are not flipped. But now, if my 2 numbers, 105 and 75, were the same 2 numbers over here, that will make it an isosceles trapezoid. If you notice, that's what I did over here. My picture, the 2 numbers that I chose were 105 and 75 for each side. For the other side, like parallelograms and rhombus and all this stuff, when it came to angles, let's take a look at a parallelogram. When it came to angles, they could also add up to 180. I could also use 180 here, but on the other side, they get flipped. It would have been 80 and 100. Right, that will happen on a parallelogram, rhombus, rectangles, squares, all this stuff. The other side, they get flipped. But in this case, they don't get flipped, so that's why it's a trapezoid. And then the numbers on the sides, obviously that's just the length, just for you to know which one is equal to which. Does that answer your question? Right. Any other questions for the front side? Yes. So I'm assuming no more question on that. All right. Any other questions for the front side? No? Okay. Make sure you guys are ready for the quiz on that tomorrow as well. Let me flip the page. On the back side, I have translations. So let's just grab the image of the figure using the transformation given. Since I have the picture and I have the instructions on how much to move, I'm just going to move each of my vertices, right, the corners. Let me make this a little bit smaller. About right there. So it says 3 units to the left and 5 units down. So let me move my x. 3 to the left, 7 down. That gives me my point x prime. But look at W. 3 to the left, 7 down. That gives me my W prime. My V, let me go 3 to the left, 7 down. That gives me my point V prime. Don't forget to write the prime on each. Don't use just the letters. Make sure you write the prime on them. And then just connect your dots. For translation, the picture doesn't change, so it should look pretty much the same thing. Assuming that my segments were straight, I say they will look really good. So that gives you guys what? 4 questions? Up to 12. You notice for 9 and 10, for I'm using words, like how many units to the left, how many units down. For 11 and 12, I'm using the notation. So you guys should be good with those as well. Any questions up until number 12? All right, 11? All right, let's take a look at number 11. For number 11, x plus 3, that means 3 to the right. Y plus 5, that means up 5. So let me look at x. Let me go 3 to the right and 5 up. That gives me my point x prime. Looking at W, 3 to the right and 5 up. And I'm doing it to each of my corners. Looking at Y, 3 to the right and 5 up. And then lastly my V, 3 to the right and 5 up. That gives me my point V prime. I'm just going to connect my points. And there. All right. Any questions on those? Now, for number 13, I'm asking you guys to write the rule. Write a rule to describe each transformation. So I'm going to say it's a translation, as I know I'm dealing with translations only. And I'm going to say xy becomes, what are we doing to the x's? Adding 1. So we're going to say x plus 1. What are we doing to the y? Adding 3. So we're going to say y plus 3. So 13 and 14, that's it.
How do you know when to add 1?
You look at the x's, like from, let me compare the x's on my point z. What do we do to 1 to make it 2? Add 1. And if you notice any x, that's what they're doing. That's what we're doing. We're adding 1 to the x. And then do the same thing to the y. Okay. Let me take a look at question number 15. Find the coordinates of the vertices of each figure after the given transformation. So I need to find the coordinates of k prime. We have to subtract 1 from the x and add 1 to the y. So I'm going to come over and I'm going to get 1, negative 2. What do you guys get for j prime? 0, 3. Nice. What do you guys get for I prime?
4, 1.
4, 1. Once again, we subtracted 1 from the x's and we added 1 to the y's. For questions 15, 16, I'm giving you guys a notation, like with pluses, minuses, but then 17 and 18, I'm giving to you guys some words. But you guys should know when we add and when we subtract. Any questions? Okay, let me take roll really quick.